Okay, so let's have an example for binary searching. So for example, we have the array list negative 1, 5, 6, 18, 19, 25, 46, 78, 102, 144. And then let's have it here. Let's just illustrate it with a table to make it as an array list. And then let's have put the position or the index in below the array list. This is position 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So this means that we have 10 elements all in all. So again, our target is 6. So we all know that 6 is there, but how are we going to justify that 6 is found using the binary searching algorithm? So again, we need to have the first, the last, the mid, and we need to have the comparison. So in this case, our first is 0. Our last here is 9. So how to get the mid again? So we need to compare the last to the first position. If first is less than or equals to last, then we can get the mid. So to get the mid, so that's 0 plus 9 equals 9 divided by 2. So in that case, so we are going to get 4 only. Okay, so again, you need to get the whole number part in getting the mid. So 0 is less than or equals to 9. That's true. So if that is true, we can get the mid. Getting the mid is middle or mid equals first plus last divided by 2. Then you just get the whole number part, and that is 4. So 4 is 19, so we can compare. So 6 is less than the value of 19. So that means the value of 6 is at the lower half. Okay, so this is the lower half. So if that is the lower half, we're not going to change the value of the first, it's still 0, but we're going to change the value of the last position. So the last position is here. We already omitted this portion because we can found the value of 6 on the lower half or on the left items of the array or of the list. So in this case, how to change the value of the last? It becomes mid minus 1. Mid is 4 minus 1, and that is 3. Then again, test the value of the first and the last if it's less than or equal. So 0 is less than or equals to 3, then we can get the mid. Getting the mid is 0 plus 3 divided by 2, and that is 1. Okay. Now, so 1 is 5. So to compare, 6 is now greater than 5. We're going to look at the upper half of 5, and that is this portion. Okay, so that means we're not going to change the value of the last, but we're going to change the value of the first. By getting the first, we're going to just simply get the middle element or last. First is equals to last plus mid plus 1. Again, in getting the first index, since we're talking about the upper half, first will be equals to mid plus 1. Our middle element is at position 1. Okay, that's the 5 earlier, plus 1, and that's 2. Then again, test the first if it's less than or equals to mid. So that's true. 2 is less than or equals to 3. Then getting the mid is 2 plus 3 divided by 2. So this is 2 plus 3 is 5 divided by 2 is 2. Okay, so here, the middle element is already the 6. So this is 6 is equals to 6. So that means we already looked and we already get the item from the list. So how are we going to stop the execution of the loop? We're going to change the value of the last, of the first to last plus 1. So this becomes 4. And last now is 3. And again, still the mid value is 2. So again, we change this portion just to simply force exit. I'm going to type here, force exit, okay, the loop, since you already found the value of the, which is equals to the target value. So again, if we repeat the execution of the loop is 4 less than or equals to 3, that's false. That means we're going to stop the execution of the loop. Then finally, what is the final first? Final first is equals to 4. Final last is equals to 3. And final mid is equals to 2. And that's the example on how are we going to get the value or the target value using the binary searching algorithm.